Hi everyone, my name is Liran and thank you for joining me for my session on securing containers by breaking in. Today we're going to talk a lot about open source security and how it relates to our containers. How can we make it more secure? Before we go off, I want to introduce myself. My name is Liran. I'm from Israel. I'm a developer advocate at Sneak, where we build developer-first security tools for open source developers and helping them just build more secure software using open source software. When I'm not doing that, I am working with the Node Foundation, working within the Node Security Working Group, helping put processes and triaging third-party vulnerabilities in the NPM ecosystem, which affects all of us in NPM and JavaScript. I'm also involved to an extent with the Node Goat project for OWASP, which is an educational web platform to help you understand what are the OWASP top 10 security risks, how can you defend against them, and all of this in a Node kind of in the Node.js platform itself. I've also authored a couple of books on Node security. If you want to reach out and talk about any of this, you're welcome to reach out at Twitter. I'm at Liran_tal, and we can have a chat. So before we move on and talk about all of the containers and all the possible issues you can have in there, and we're not going to talk about all of them, but I'm going to have a few best practices here and what can you do to mitigate it. I do want to talk about how much you really know about your open source dependencies. And you have those open source dependencies, in containers and in your language-based ecosystems, which is actually what I want to start with to just get us off on the right mindset here. So I've read this interesting research paper that tried to compare NPM and Python, or like PyPy, which is Python's language-based ecosystem. And one of those highlights that it had, at least one of them, was that NPM had featured about 61% of abandoned packages. Now, NPM is by large the largest open source package registry that there is today for language-based ecosystem. We're talking about more than millions of packages there, and anything that comes close is in the numbers of a few hundred thousands. So nothing comes close. It's pretty big ecosystem, and still out of these more than a million, probably about 1.3 million packages, all of those open source packages, 61% of them are have been defined by this paper as abandoned packages. And the way that it defined them as abandoned packages is saying basically anything that did not receive a release within the last 12 months, when we checked it, we would consider it as an abandoned package. Now, granted, you could think about this as well, maybe the package is simply very mature, there's no features or bug fixes to push in there, except sometimes what we realize is the harsh truth, and that is if we take the event stream incident, which happened. This is a security incident that happened just around 2018, not a whole long time ago, but affected a very very big chunk of the ecosystem itself in terms of what it could actually mean. This is a package that had been there on the registry since 2011, so for a whole lot of years, many packages. But it suffered this case of a security incident where a malicious package was actually injected into this dependency tree. So if you installed Event Stream, you would actually install a very malicious package, that affected actual cryptocurrency wallets in terms of it was able to now go ahead and get money transferred for those affected in it. So the issue here is really about how much do we know about our open source dependencies. This is one example. The other one, which the article or that research paper touches on, is the fact that if we use open source packages, this dependency graph that we build, all of those dependencies, one requiring another, could actually grow very big. And it is beyond just the direct packages. We're talking about nested trees. So for example, the average NPM install that you would run on a project will actually yield back more than 4 levels deep of nested dependencies. So this is the risk, this is the status that we have to take open source dependencies in the NPM ecosystem as an example. And if you think about, where do we find most vulnerabilities, it differs from ecosystem to ecosystem when you look at language-based ecosystem, for example, Python or NPM. But the interesting case, again, with NPM is most of the time, so about 78% of the time or so, when we find open source vulnerabilities, we will actually find them in those indirect dependencies that you build into the project. So that means even if you're actually tracking the change logs and security announcements for direct dependency added to a project, That's nice, but most of the time I actually find it in indirect dependencies. So these are dependencies that actually can't control that much, those indirect dependencies, but it is, and usually we're not even aware of all the exact tree that we have. But again, most of the dependencies come from that. For some of these ecosystems, npm very obvious here. What can possibly go wrong with such indirect dependencies? Here's a story of malicious packages on npm 2015 till 2018. See a couple of names here. I'm gonna talk about get cookies specifically, and figure out, well, what could actually go wrong with a dependency in my project. So get cookies is actually a malicious package, right? It doesn't look like it, but it is. It is supposed to parse HTTP headers. It probably does that for cookie data, but it is actually a malicious package. If you installed it, you immediately provided someone access, and actually not just access, but a backdoor command and control access into your web server if you bundle this dependency. This is the whole purpose of why this package was built, simply for that. The way it did that is through about 40 so lines of code. There's like 23 lines of code just summarizing how it actually works. So it has 3 use cases if you follow the switch cases. First of all, it's going to be able to receive a command to clear the buffer and make some room. The second one is it will load data into this buffer, so any JavaScript that you will send it for later on, evaluating it. And third one, it's going to run everything that you send it. So clear the buffer, send some JavaScript you want to run, and execute it. That's the whole command and control in this backdoor. This is a real package that existed on the npm registry before someone took it off and people found out about it. Thing is, just a package out of 1 million of packages on the npm registry doesn't mean anything, because if you Google forget cookies, you might find it have 5 downloads. You will not download it. But if it hides in kind of a nested tree where get cookies is there, but actually it's being wrapped by express cookies and then being wrapped by HTTP fetch cookies, that's a different story. Maybe it's now going to be hard to code review all of those nested dependencies to find all that horrible code in get cookies. Still, all of these packages and this tree doesn't mean a lot, because no one will install HTTP fetch cookies if it doesn't have credibility, if it doesn't have enough downloads. And so what happened really in this story is Mail Parser, a different kind of package altogether, was compromised. Someone was able to get access to publish a version of Mail Parser that included HTTP fetch cookies. So basically, they injected that as a dependency to that project called Mail Parser, and through that, presumably, attempted to cause some kind of credibility for this whole tree of nested dependencies, which are evil as we know it today. So what I'm trying to say, this is like a mental exercise that I want to do with you together. So imagine that you build an application, this is your application. Could be in Java, could be Node.js, but your mental image of this application is the following yellow blob, and you're thinking, I'm going to release this to production. This is what goes into my CI and then production, etc. Except the reality is a bit different than that. As developers, we think that we're shipping this whole piece of application out there, but the code that we actually write as developers is significantly smaller than what we actually ship out. And researchers, are talking about something around 90% of open source code that we actually rely upon, then 10% of code that we actually write ourselves, and even that is sometimes a very generous addition into it. So let's talk about how this relates to containers, right? Containers are also based on open source. We have a lot of containers out there. If we talk about the adoption of application container technology, it is an increasing and remarkable state. We're talking about expanding this, year over year. And Docker Inc. itself, the de facto library behind what we have as Docker Hub, it's talking about more than 1 billion weekly downloads of container images. Those are basically applications. And it actually reported that, the following year, last year, we had almost 1 million applications in the form of container images that were submitted into the Docker Hub registry. So we're talking about a lot of open source components going in, and all of us using it. But the thing is, in this talk, what I want to actually focus on is the best practices for Docker image security. So what can go wrong, and how you should do things to make sure that they do not go wrong when you're building Docker images. for your applications, whether they are Node, Python, doesn't really matter. This takes for all of this. So first off, I want to begin with, prefer minimal base images as a very first rule of thumb to start with. This has a lot of other good side effects, besides, what we'll go through here. But just having, that minimal base images is going to reduce a lot of friction for us in terms of security. So let's talk about it. Oftentimes, when you start a project with a generic container image, you're probably gonna have like in your Docker file, from Node or from Python or something else, and this is gonna be your kind of like your default image. However, when you specify, from Node as an image, you actually take into consideration that you're gonna install this full Debian or Ubuntu-based image, and so this distribution includes in itself, a whole lot of probably libraries that you do not need, command line tools that you do not need, all of these things that actually add up to your base image and what you actually build your application on top of. You get this full-blown application image. The thing is, if we had now scanned all of these top 10 container images by default, or their Node and latest kind of Docker images from the top most popular container images on Docker Hub, this is what we'll find. We'll find that Node has 580 vulnerabilities inside it. We'll find that all of them have at least 30 vulnerabilities included in that latest tag, the default tag for for Mongo, for MySQL, for all of this. So it's probably not the best idea, as you can already imagine, to bring in vulnerabilities into your Docker image by default, just like doing that. So the idea is, this is where we need to be very mindful on the Docker image tag that we're actually pulling in, because Docker images almost always bring them with themselves vulnerabilities, so we want to be able to avoid that. Now this relates again back to open source, because of course those containers are probably going to be based on some variants of Linux, and as you can see, this is a trend graph showing you that basically vulnerabilities increase over time when you do use open Linux as your base image, and we do find more and more CVEs and more vulnerabilities in RHEL and Debian and Ubuntu based Docker images. So we're not finding less vulnerabilities. The thing is, if we look specifically at a breakdown of vulnerabilities, say high and critical vulnerabilities, what is interesting, is that we're actually for 2017 and 2018 finding more high than critical, right? That is, more high and critical altogether, and that is something that is also something that we need to pay attention to. So more vulnerabilities, but more of them are also high and critical. The next thing is, having least privileges users. So when you build, your Docker file and your Docker images, what you actually want to optimize for, we do not want to forget is the notion of the least privileges, by default. This is kind of like a 20 years kind of like best practice around Linux, admins. So when a Docker file doesn't specify a user, it means it defaults to, the default, which is the root user. The root user, if you do not specify any other user, will actually will be the one that is mapped to the container image that is actually running in production as well, or wherever you execute the Docker container image. And the thing is, that's probably true for a lot of Docker images by default, unless they specifically specified that next users will be non-root users, but that's almost never the case. And so this means that you're insecure by default. So just as an example, if I'm using the Ubuntu as a base image, which looks kind of like this as my Docker file, from Ubuntu I have make dir app, if I skip the whole yellow lines there and I just ran node index.js as my executable process for this Docker image, what will happen, I will default to the root user, and the root user will be the one that actually runs this process. Usually this maps to one-to-one root user on the host machine if it is not configured in like a different environment. So what we do want to pay attention here is to fix it. You want to add group add Liran, section whatever you need, and then switch that to user, so user Liran tal before you execute the application. This is second best practice. You should probably be able to use a low privileged user when you're running executing your Docker images. If you're using Alpine, you're not taking that very bare bones, kind of like Ubuntu image, doesn't have any specific Node stuff in it, and say you're using Alpine already comes with the Node user. So all you have to do, you not even need to create it. So this is a very least privileged user. All you have to do is use this user node and then execute your process. Let's talk about number 3. So how do we enable 2FA? What is even 2FA? So two-factor authentication couldn't be news to anyone these days. But the thing is, we put a lot of trust in these images, and we are literally, using them, as our containers that run in production. Sometimes we build it, sometimes we use it. It's very critical that we make sure that the images that we use have not been altered to contain any malicious data inside them. Not to crypto mine, whatever is running there in production, as well as, we do not want to allow anyone to actually exfiltrate data or do any malicious things in it. And so let me ask you about two-factor authentication. How precious are your container images? How sure are you that no one else, had actually messed up with the images in any way? And so two-factor authentication allows us to ensure that, when we build, Docker images, our user that builds and sends a tag to the registry to Docker Hub, is actually protected with two-factor authentication. That means no one else was able to just brute force our password or just guess it by chance or by luck, or, just by using some kind of leaked passwords database to log in instead of us to the actual registry and send in a newer version of that image. To get into that kind of mindset, I do want to talk to you about what happens with two-factor authentication in another ecosystem. So let's talk about the state of 2FA, two-factor authentication, again in the NPM registry. So this is a language-based, not Docker container images, but the language-based kind of like open source repository. NPM is, as we said, the largest there is. So it's an interesting take to see what's going on there. As we talk about it, if you had to guess, how many developers actually enable 2FA, this is a stat that is kind of, few months, maybe dated a bit from last year, but still somewhere around 7 or 10% of all developers on NPM have two-factor authentication. This is despite the fact that two-factor authentication has existed on NPM since 2017. So for a whole long time, it existed, yet, a very low amount of the developers on NPM have actually enabled it. So definitely if you have one, you should enable it. But what happens on the Docker container ecosystem? What happens on Docker Hub? How many people have actually enabled two-factor authentication for their users so that their accounts are actually protected? What about zero users? Actually, zero users. Yeah, that's kind of it, because this study is reflecting what was the status until October 1st, 2019. So not a whole long time ago, actually very recent. But why is it zero? Well, basically it's because we did not have 2FA until that point of time in Docker Hub. The one that gets billions of downloads every week, the one that gets millions of applications, a year. So we started off with, it's an interesting thread from this GitHub issue queue for Docker Hub, for that project. Someone chimed in and said, we're now planning to roll out this starting end of June. Everyone, of course, thumbs up, amazing, let's see 2FA in the ecosystem, we'll enable it for my user afterwards, etc. Except it didn't really happen at the end of June. So someone chimed in and said, hello from July. What do you think happened in August? That's right. Nothing new under the sun. Hello from August, I like the irony here, how hard is it to implement 2FA? Don't lie to me, I'm a programmer. That's the thing, right? We have this issue where we expect 2FA from Docker Hub, and it's not yet there. Not the end of June, not July, and not in August. September is no change. October, slight good news. There's a quick update from the same guy person, I don't know who they are, that actually announced the fact that we are going to support 2FA. Except this is not an announcement for 2FA. This is an announcement for rolling out access tokens, which is not the same, but still good news that we have it. And to make this story short, then someone else chimed in and said, we do have 2FA. It was launched today. It is in beta, actually. So we do have 2FA right now, and you should definitely go ahead and enable it. Regardless of Docker Hub, you should enable it for all accounts that you're actually using and consider, very critical, mission critical for your systems and what you're using them for. but just to state the fact that 2FA was not even existent about 6 months back in the ecosystem. So definitely this is the state of how we should really understand what is the ecosystem's hygiene for developer security, and that is 2FA needs to be enabled there. Luckily it is. Let's talk about signing and verifying images. If we talked before about the idea of being able to pull an image and, at least I know no one was able to maliciously, compromise my account and, send a different image with malicious data in it. That's the 2FA part of it. This one is also about the idea of understanding that those images, you want to sign and verify that those images haven't been altered by any party, whether this is the medium, right? We all work on HTTPS, probably, right? SSL and all of that. But sometimes it is able to compromise those images in different ways. And so you do want to make sure that, they were signed, verified. And the way that you do that today is with Notary. So if you open up the Docker Hub, this is a screenshot from a bit back, but if you open up the Docker Hub website, you'll see this verified publisher, which actually means that all of those verified publisher labels on images that you see there, or, the projects on Docker Hub, that were certified as well, means that they have actually been signed and vetted by their parties, and the Docker team behind Docker Hub had actually vetted that this is true. So definitely optimize for those first. And if you do want to be able to get signing and verifying images into your workflows, what you should probably look at is how you get started with Notary. The Docker Hub itself has a Notary server inside it, so you could actually sign images and work with the Docker Notary server that actually exists. You do not need to. Notary is an open source project. You do not need to roll that on your own unless you actually want to. But if you are using Docker Hub as a registry, this is already solved for you. Once there's a whole need of details that we need to get into Notary to understand how signing works. But basically, it's based on the update framework, which is an open source spec and a framework tool. Notary is kind of like built according to that spec and allows you to do all of those signing and image and verifying that we've been talking about. And the thing is, once you do go through that process, if you simply configure Docker, the client, say, having this environment variable content trust equals 1, you enable it. That actually means by that now if you try to get an image or run any operation on images, say Docker pull, Docker exec, Docker publish, all of them will actually go through the signing and verifying instance. So if I try to pull something right now after running this, that is not a verified image, the pull will actually halt and will not let me proceed because that image was not signed. Let's talk about finding and fixing and monitoring those open source vulnerabilities in the OS, right? In our containers. Why is this even important? We've seen Node by default has the latest tag has almost 600 vulnerabilities in it just by default when you use it. And the thing is, if you understand closely how Docker images or those base images that you base your project on are built, it's actually interesting to understand, why those vulnerabilities actually come into play. So Node as a project, for example, is based on build back depths. It's based on that in the sense of this is the actual base image that Node itself is building upon. And when you use build back depths as a Docker image by itself, it has different tags to go with. So if you choose to run, the default Node image tag based on build back depths :Jesse, you'll pull in 700 vulnerabilities just by default. If you choose to build it on Bionic or Cosmic or something else from the Ubuntu distribution, you'll get 140 by default, which is not bad compared to 700. Still bad, but not that bad. So the idea is this is how all of it kind of transitions from the very upper the way that you want to imagine it, but from the upper kind of like chain of like build back depths, then Node itself, and then your own Docker image that actually does from Node. So this is how this whole kind of things connects. And we've asked in this survey that we ran last year called the State of Open Source Security, some questions around how do you manage Docker images, the security around it, and what do you do about it. And the interesting thing, as I'm sharing this here, when we ask people, when do you scan your Docker images for open source vulnerabilities, 50% of them actually don't do it. which is, we'll talk in a second why it is so easy, but like it's already an alarming state, that 50% of users simply do not even track vulnerabilities in their containers. Now you can use a lot of tools for this. I'm actually obviously gonna talk about Snyk. It's free. You can try it out. It's free for open source. Even if you use private projects, there's like a threshold that is free for that. So you can go ahead and try it out, and it's as easy as Docker pull whatever you want to test. For example, Node 10, then running the Snyk CLI with this kind of command to tell you, well, I found this and that vulnerabilities. And the thing is, just finding vulnerabilities, like if Snyk test would tell me here I found 700 vulnerabilities, that's fine, but it's not really helpful. So if I used, for example, the Snyk UI to test the node image, you can see there's, the image tag is 10.4.0 in the middle of the screen. And if you look, to the left, you'll see vulnerabilities 862 out of 7,000, so more or less paths. The thing is, by itself, this information is important, but not helpful for me as someone who owns the Docker file, want to make changes, want to say, well, how do I remediate all of those vulnerabilities that I have there? And this is where the tooling actually makes sense, right? The tooling, the Snyk CLI output or the UI output, like you see here, will actually tell you these are recommendations that I can give you for base image upgrade. So this is about actually solving the whole dilemma of open source security as much as it relates to container images. For example, it will tell me, you can move from, you are on node 10.4.0, but which has 862 vulnerabilities. But if you move with a minor upgrade from node 10.4 to node 10.16, you already get 200 vulnerabilities less. Already in a state, in a path for a good state. And we can move on to, different images as well, like a Node Slim and Jesse and maybe Alpine, to get to as zero as as close as we can to zero vulnerabilities. So this is where tooling actually helps. How about the fact that now that you've got this kind of talk into the whole mindset of Docker security, how about this kind of statistics saying 40% of those Docker image vulnerabilities that we actually find, they can actually be fixed by just moving to newer base images, right? So it actually emphasizes even more the fact that you can 50% of the time almost, just by moving to a different image tag. If you know which image tag to move to that has less vulnerabilities in advance, that will fill the CI and tell you, move to a different one, that's already gonna put you in a better state of having less vulnerabilities in your Docker images. So again, like, why would you not do this? Now, if we take a look specifically at Node, I'm coming from the Node ecosystem, so these examples are kind of like relating to Node, but you can probably take this and project this to other base image tags, Docker images that you're using in different ecosystems. But if you look at it at Node specifically, you see Node 10, which again, Node 10 is the long-term support. This is the actual, maintained support release that you want to be at. But if you just use Node 10, you're again taking in 582 vulnerabilities into the project. But if you know to use Node 10 Slim or Node 10 Alpine, you'll get much less. So this is something you should. I'm not saying you should probably do it by default, because you could have vulnerabilities in Slim that is much higher, or vulnerabilities in Alpine that are much higher than zero. It's just a matter of time of like, when do we actually get the CVEs out, and are you able to like actually use the newer base image, the newer tag that was actually built. So you should actually go ahead and monitor it. But here's another statistic for you. 20% of Docker image vulnerabilities can be fixed just by rebuilding them. So a lot of time what we see is people in their Docker files do things like apt-get update, apt-get run and upgrade and install, and just by rebuilding the image, you actually modify it. So like maybe 5 consecutive installs of a Docker image will have different actual artifacts out of it, because you're actually always upgrading to the latest, and the latest can change between when you build it at first into CI and then when it went into production. And so that actual rebuild can actually reduce vulnerabilities, because you will actually upgrade software maybe to the latest. So you will actually get security fixes in. So if you are using that notion of rebuilding images, not rebuilding, but if you're using that notion of doing apt-get upgrade, like installing packages in your build process and not relying on the actual base image to have whatever you need, then you're actually mutating the state, so to say, and actually by rebuilding it more often, you could actually remediate the vulnerabilities, because you're actually pulling in latest fixes. So just having this kind of idea into it would help. And so, interesting enough, we asked, how do you find about new vulnerabilities in your deployed container? So anything that is in production, anything that, has made it or, past the development process, now it's in production. Will you find out about the new vulnerability that hits that, that Alpine 10 or whatever that node container image that you're using? Well, again, almost 50% of people will not even find out about it, which is, it is sad because it is very easy to do it. So whether you use Sleek or any other tool that you want to use, do whatever works for you. But it is very easy today with this tool that we have to actually do this. So please, adopt this best practice. And the thing is, what can possibly go wrong with container image vulnerabilities? So, you're using an image, but what can go wrong? So to give you an example of all the things that could, have bad problems when you're using container images and they have dependencies which have vulnerabilities in them, I chose this example. We chose this presentation from Google I/O. It's on YouTube. You can find it. You can watch the whole stream. But I've given you just one. I based my example for an actual demo, live hands-on hack that we'll do into a container image, running container. Based on this example, based on this story. So what they're showing there is that this application is built on Node, and it gets uploaded images, and what it does, it converts them to a thumbnail with a different size. Does something with it. We don't really care about it. But the thing is, if you paid attention very closely, something will jump in to what's going on here. This should jump in, and be very interesting for you. So what's going on is the Node web server spawns a command, so creates a system call for a CLI, for a tool called convert, which is based on ImageMagick, right? That's even the comment is saying so. So Node by itself it doesn't have any libraries or way to convert the image from one size to another. It's actually relying, maybe it's installed on like an Ubuntu, or ImageMagick was specifically installed in that container image or this OS to actually convert the images from one size of the image to a different one, this thumbnail, for example. So I'm going to go ahead and build on that. And the thing is, ImageMagick has a lot of vulnerabilities. So if you look at, this is from a screenshot from this, like the Sneak database, which is open. You can go into sneak.io/vuln, see all the vulnerabilities, depending on which ecosystem you want to look at. And you'll find a lot of vulnerabilities for ImageMagick. And this one is actually the one that is very interesting, because this vulnerability affects the ImageMagick that you have installed as a CLI on the OS. If you have this specific version or these version ranges, that you can see it's affecting Ubuntu and Debian and different other vendors of Docker images that you may have this vulnerable version of ImageMagick running on top of. And when it came out, it wasn't that strong of an impact in terms of these vulnerabilities. So what the security researchers here did was actually create a website, and the name for the vulnerability for this CVE, it was called Image Tragic. And we know these names from like Shellshock and Heartbleed, but Image Tragic has also been a thing, and they created this just to make it into the mindset of everyone to understand how big of an impact this is. So what can possibly go wrong with vulnerabilities in my container image? And this is where I want to take you into a bit of like hands-on example of what happens there. So I'm going to move in here to show you how this container is running. I will try and make my screen as big as I can. So what I have here basically is a Node project. It's a web server. I have the package.json, everything installed. Have a Docker file. I have everything running. I am going to not stop it. I will run this container. And this is basically a small web server that I built that helps me. There we go. We can take this over here. This should work now. And it helps me resize images when I want to upload into Twitter. So before we go in, what I do want to show you is I will now sign in to the Docker itself. I should be able to do this. and I can, well, I mean, shell into the Docker, the running container itself, and see what's inside. You see this is basically the same image that I've built. There's no other file here called RCE1, but we will create it out of a vulnerability that exists in a dependency inside this Docker image. So if I go ahead and choose to upload a file, I'll call it RC1, and I'll upload it, call it resize. What I'll actually get here, if I just refresh this again, is a file. It's empty, but I just actually now created it for the sake of showing you that I'm able to actually run a command. This is remote command injection into a running container due to the fact that I was actually using a container with vulnerabilities inside it. And unfortunately, one of them was this image tragic vulnerability. So, you know, a lot of other things can of course go wrong from this point, but just to show you how bad, you know, things can happen just with that. So let's talk about using linters. Linters are a helpful way to go ahead and check what configuration we have. It's like static, you know, code analyzer. They can check what you know, bad decisions we've made, you know, in an accident or maybe not, but just like bad defaults and stuff like that. And you know, we use them a lot in the JavaScript ecosystem. I'm pretty sure they are used a lot in other ecosystems as well. And the idea is they actually help us, you know, adopt best practices, because they have these like, this is the guidelines of how images, you know, should be built, and you know how Docker files should be authored. And if you're doing anything different, they will tell you about it. So here's an example. I'm gonna tell you about maybe a few of them, but one of them is called Hadolint. And Hadolint, you know, you can use it in, you know, you can install it. You can use the actual Docker image for it to run it on a Docker file. But once you run it, it can tell you a lot of things that we actually talked about here. For example, the fact that you should maybe do not use apt-get upgrade or dist upgrade. That's not a good idea. Or delete whatever you have afterwards. Or, you know, for some of the times it will tell you you should pin your dependencies if you do install something, so you do actually maybe do not get latest, just because you want to make reproducible and repeatable builds and do not modify it. You should use copy instead of add. You should, you know, you did not add the user into your Docker file, and so what happens is that the user is now you know, being root as a default. So definitely make use of those Docker container, of those static linters, whether you use them with Docker containers, just install them by default or not. The other thing is I want to talk about is application dependencies and the impact that this really has on the container security too. So for example, what I mean by that is where you have maybe the Docker image and the container running with, you know, as minimum vulnerabilities as you can reduce it to. That is great, but then at the same time, you also need to make sure that the application running on the container is indeed, you know, not vulnerable, right? It is using up-to-date dependencies, open source dependencies, and packages that it has that have no vulnerabilities inside them. And so to kind of like iterate this example, what I'm saying is, if you build your app, going back to this example, right? If you build your app, you know, you're going to have some dependencies inside it, and, you know, your code is just a small part of it, right? And actually, if you think about it, we have the same graph as we've seen before with what happens on the Linux, kind of like the OS trend. So we are seeing, as you can see, an increasing trend of, you know, finding more and more new and new vulnerabilities on language-based ecosystems too. So, you know, new vulnerabilities in NPM and in Golang and all of those ecosystems, you know, are on the rise as well. Reiterated how difficult it is to understand what is, you know, I think it is hard to imagine even like writing software today without using any open source dependencies. But it's not just the dependencies that we use, it's the dependencies and dependencies that they use. And so having this idea of direct and indirect dependencies and understanding that vulnerabilities can come from different areas inside it is, you know, is complex, but it also helps us understand that, you know, this complexity, be aware of it, and then make sure that we actually scan those projects as well and all of this dependency tree to get all of those vulnerabilities, you know, floating out so we can actually fix and remediate them. Now, the thing is, what can possibly go wrong with vulnerabilities in my application, right? What can possibly go wrong? So let's talk about something. I want to show you another demo. So let's stop this container for a second. Let's exit this one and Docker stop or say should stop it. Let's move into a new project. So here I have another application server. It is waiting on port 3001. There we go. So if we switch to a different one, and so this is another to-do app, right? You can do a lot of things here and just run it. I see a way to upload files, which is interesting. Wonder where the vulnerabilities lie. And I have this about page, which you can see this about page. But what's also interesting is this is a public address. So maybe what I have here is a way to traverse out of this tree and actually access data in the container itself. So I can actually move from the application vulnerability and that attack surface into the container itself. So what happens if I take that and let's hold on. It's too many windows. Okay, there we go. We can focus on the top one. And I can go ahead and try to get into public. And when I do that, I just get nothing but the CSS, the images, the about page, nothing. Through that, if I try something like that, I get the upload form and the to-do list. So I can't get I can't do path traversal here, which is sad. Except I know that there's a vulnerability here. Like if I go inside, I see that I'm actually using this thing called ST024 to host this to host all of these public resources that I want to serve, right? And so if I search this vulnerability database and I search for ST, I see that anything beyond 025 actually is susceptible to directory traversal, to path traversal vulnerabilities. So this page actually shows me even how I can go ahead and exploit that. I can just go ahead and, well, apparently what happens is this package is it's actually checking maybe for // to stop path traversal, but it's actually not checking for URL encoding dot, which is %to e. So if I use that instead of // I can actually traverse back on the running container. So just running something like this takes me back, right? And if I run more and more of those, I can go back all the way. So you can see this is the actual container image itself running here on the left side. So on production, on dev, wherever you want this container image, this is coming from the application dependencies, not just the vulnerabilities in the dependencies on the container on the Docker image itself. So again, showing us how how things can go bad if we do not take action there. Now the last one is about multi-stage builds. And this is where things get interesting. This is not a new feature, but it's definitely a way to build Docker images in a saner way. In terms of what I want to talk about here is the example that I always give is Golang. For example, with Golang, if you want to build a container image or a Docker image in a container out of that, what you would usually need is a whole set of cross compilation tool chain that you need to have on the host itself to build it, to compile that Go binary. But the thing is, if you then need a very fat image with all of those libraries and tools installed, then that's gonna take, gonna bring into the Docker image a lot of assets that we don't really want, and gonna make it a really big image as well. So the idea is with multi-stage, we can go and say, I have a build image. I have a build image step in which I want to compile, set up my application, build that the Node image or the Golang image, all of those. But then I have a new image that will actually be used in production. And what I will do, I will take all the artifacts that I created from the build step. So when I compiled Go into the native binary, or I installed all the npm node modules, I'll take them out of that and then copy them to a new very slim base image without anything that I need, and it is then very small, goes back to my number one best practice, which is, prefer small base images. And so imagine you have from node 12, you need to run installs for your npm project, but you need to add a token for it, add and put it into an npm RC. So now the Docker image has this token and this secret, but then you actually want to go ahead and build a safe image which doesn't have it. So this is showing us this multi-stage build. We're actually building Node 12 Slim, very small image, but then we're taking the Node modules from the previous step and copy them over. And so to kind of like end this talk, I wanted to say that, attackers are targeting open source because finding one vulnerability means many victims, because many use cases of this dependency used throughout the project. So iterating what we just said, choose the right base image, prefer small batch images, rebuild often, scan your Docker images, use multi-stage build if you need to. Obviously, enable two-factor authentication and use a linter to link your Docker file or Docker Compose. If you want to, go and review any of those, you're welcome to get this Docker image security best practices cheat sheets. And there's a whole blog, iterating a lot of it, and all of the data that I talked about here and a little bit more is in that. And you can always ping me on Liran_tal on Twitter. I'm gonna be happy to talk to you. Thank you for tuning into my talk. It was a pleasure, talking to you and presenting this. So containers are cool, but be a responsible kid and use it wisely. Thank you. Bye bye.